When you're working with Dolby Atmos, you relatively quickly run into the issue that you only have 7.1.2 bed tracks. That is a problem because you only have 2 overhead speakers, and with only 2 overhead speakers, you can't really do fully immersive 3D spatial audio. The standard trick to get around that is to split up the bed channels into those channels that have a representation in a traditional Dolby Atmos bed, in particular the horizontal speakers, and route them into the bed channel. And all the speakers that are not represented in the Dolby Atmos bed, in particular any overhead speakers or any other speakers that you don't have in the bed, are then routed into objects and positioned as objects in 3-dimensional space. Some Dolby Atmos production systems actually have a prepared workflow for that. The Fiedel Audio Dolby Atmos Composer, for example, has something that they call composites. And a composite is exactly that. It consists of some channels that go into the bed and some channels that go into objects, where these objects represent all the speakers that are not represented in the bed. So the question is, can we do something similar in Ableton? And the answer to that is yes, we can. And that's actually very easy to do. And this is what we're going to do today. So today, Dolby Atmos bed tracks with more than 10 channels in Ableton. And it's actually fairly easy to do. Let's get started. Before I get started, a couple of comments. First of all, I'm going to use Ableton today. However, the main trick that I'm going to show you works with many digital audio workstations, in particular with Reaper. The only thing that you need is a digital audio workstation that can route different channels from one track into different outputs, and that's pretty much it. The second thing is that because we are working with Ableton and we want to use the traditional Dolby Atmos workflow that comes with Dolby and not the Fiedel Audio Dolby Atmos Composer, we need to work with the external Dolby Atmos renderer, and that is only available on a Mac. So today I'm going to work on a Mac, and the things that I'm going to show you, unfortunately, only work on Macs. The third comment is that in a previous video I showed you how to use the Envelope for Live system in order to create a 7.1.2 reverb bed track with Ableton. Now we're not going to use Envelope for Live today, however be aware that you could also use that if you want to. So you can also use the very same trick that we're going to use today with the Envelope for Live system in order to create beds that have more than 10 channels. The final comment is that the penner that we're going to use today is the SPAT multi-channel penner from Music Unit, which is an implementation of the SPAT toolkit from IRCAM, which is a very famous French acoustics institute. It works extremely well for that purpose, but be aware that you can use pretty much any surround penner with exactly the same trick. So you could, for example, also use the surround penner that comes with Ableton, and you could do the exact same thing. And with that being said, let's hop into our Ableton project. The project that I'm going to use today is a simplification of a project that I used previously. It consists of 2 tracks, one that I call Call and the other one that I call Response. Let's just have a listen what we have. So that's the call. And this call is then answered by a response. Now, the basic idea that we are going to follow today is that we're going to move the call onto the left side of our space and the response into the right side of our space. And then we're going to add a reverb to those 2 tracks, and that reverb is going to be routed into the bed. And for that, we're going to use a 7.1.4 reverb. Now, I should point out that these 2 tracks already have reverb on them, and that is not ideal. However, for the purpose of this demonstration, that is perfectly fine. Usually, in an ideal situation, you would have completely dry objects, because if you bake reverb into those objects and you position those objects in 3-dimensional space, then the reverb is also located at that position, and that's not the way reverb works. Usually, reverb is all around us, so the best way to treat reverb is really as something that you route into the bed channels of a Dolby Atmos project. However, in this project, for demonstrating what we want to do, that is perfectly fine. So we're going to treat these 2 tracks as dry tracks, and then we're going to add additional reverb that we're going to send into the bed channels. And we're going to separate that out. So the reverb that we're going to create is going to be in the bed without any dry signal, and the tracks are going to be sent into the objects without any additional reverb. So let's have a look at the basic Dolby Atmos setup, and in this particular video I'm not going to go into the details simply because I already did a number of videos on how to set up Dolby Atmos in Ableton Live. If you're interested, I'm going to leave some links in the description below. Let's just look at the very basics here. In the Dolby Atmos renderer, I've set the input and output devices. The input is set to Dolby Audio Bridge. That's the way Ableton communicates with the Dolby Atmos renderer. The output device is set to whatever the actual output devices. In my particular case, it's the Rodecaster because I'm recording that. I've set the LPC input channel to 129, that's the default, and I've set the frame rate to 30 frames per second. And then I've set everything to headphone only mode, and I switched the render mode to binaural because a lot of my viewers usually want to hear my videos in binaural. Be aware that if you're listening to this video on something other than headphones, you might not get the correct impression. So this is a video that needs to be listened to on headphones. And then in the live settings, we need to just switch the output device to the Dolby Audio Bridge so that everything is sent into the Dolby Atmos renderer. And that is pretty much it. So if we now play the audio, we already get that in the Dolby Atmos renderer. It's coming in at channels 1 and 2 because that's the standard output of Ableton. Now the one thing that we see right now is that we don't yet get a time code information, and that also means that the loudness measurement doesn't really work correctly right now. And the reason for that is that in order to make that work, we first need to complete our Dolby Atmos setup, and that means we need to add the timecode plugin to our set. So let's add an additional track here, an additional audio track, and let's add the LTC timecode plugin. And here we have it, the LTC audio generator, and we need to set the frame rate. As we've seen, the frame rate in the Dolby Atmos renderer is set to 30 frames per second. And we are not working with video. However, we need to make sure that the frame rate matches. Otherwise, the Dolby Atmos renderer is going to give us an error. And then we need to set the audio to the LTC channel. And the LTC channel is external out channel number 129. That was the channel that the Dolby Atmos renderer is expecting the LTC information. So if you play everything now, you will essentially see that the timecode is also reaching the Dolby Atmos renderer, and the loudness measurements are also coming in at this point. So let's turn our two tracks into objects, and for that purpose there are two things we need to do. We need to route the audio into the appropriate object channels in our Dolby Atmos bridge, and we need to add the music panner to the tracks in order to communicate the panning information to the Dolby Atmos renderer. So let's do that. So the first thing I'm going to do is in the call, I'm going to simply route the output from not into the master, but I'm actually going to route it directly into the Dolby Audio Bridge. And I'm going to use two object channels for that purpose. And for reasons that will become apparent a little bit later, we're going to start with channel number 15. So let's route them into 15 and 16. Now the thing is that if I now play the audio, you're not going to hear anything, even though the Dolby Atmos renderer is receiving audio information. And the reason for that is simply that I currently don't really have any panning information sent into the Dolby Atmos renderer. And because I don't have any panning information in the Dolby Atmos renderer doesn't really know where exactly these objects are and can therefore not essentially render the audio. So in order to make that possible, what I need to do is we need to add the music panner. So let's just add an instance of the music panner. Music, I should type correctly. And here we have the music panner. Let's drop that here. And what we really need to do is we need to just select the object pair. We have object pair 15 and 16. And then we also need to make sure that the essentially this button here is green. That means that the music panner actually identifies the Dolby Atmos renderer correctly and the communication is set. We're going to leave everything else okay. As soon as I do that, I already see in the Dolby Atmos renderer these two blue circles, and that means that there is now panning information coming in. So if I'm now playing the audio again, so let me just play it again. I now actually hear that because now the renderer knows the positioning of these objects and the audio that comes through these objects and can then render them correctly. Now the one thing that I need to point out, and that is something that not a lot of people are really aware of, that these two things are sent into the Dolby Atmos render independently. And I'm going to come back to that multiple times throughout this video because it's going to be a critical component in the trick that we're going to apply. And it's something that not a lot of people are really aware of. So the music panner sends the panning information into the Dolby Atmos renderer, but doesn't really affect the audio signal. And the audio signal is sent through the regular external output into the Dolby Atmos renderer, but essentially never really reaches the music panner. So those two things are actually independent from each other, and that means that we could technically have them on separate tracks. It doesn't really make any difference where exactly in your set the music panner is, as long as it is communicating the correct panning information into the correct object channels so that the renderer knows how to render the audio that comes in these particular channels. And we're actually going to take advantage of that. Now what I want to do now is essentially the same thing that I also did in the video where we used Envelope for Life in order to create a 7.1.2 reverb bed track, and that is we are going to split up the signal, the audio signal, into two parts, and we are going to send them into different outputs. One part is going to be sent into the object channels and one part is going to be sent into the bed channels. And the way we're going to do that is exactly the same way we did in the Envelope for Life video. We're going to use a nifty little device, which is called Audio Routes. It's a Max for Life device that comes from Cycling74, the makers of Max for Life, and you can download that for free. I'm going to leave a link in the description below. And what it really does is it just allows us to add additional sends, and that's what we're going to use. So let's add the Audio Routes device. So wherever you have located or where I've downloaded that, in my particular case, it's here under PACS, Workflow Tools, Audio Routes. And what we're going to use is we're going to use this device that's called Audio Sends. And this now allows us to add additional sends. So we can, for example, add an additional external output and send that to output 1 and 2, or any other output that we want. I'm going to turn off the additional gain knob here. We don't really need that. And what I can also do is I can mute the output that I'm going to send this to, and I also can adjust the gain in case I need to. And I can actually kind of have multiple sends here, but I'm only going to use one. So the next thing I'm going to do is I'm actually going to switch the outputs around. So instead of routing the track into object channels 15 and 16, I'm actually going to send the audio through the audio sense device into channels 15 and 16. And I'm actually going to switch off the audio from the regular track completely. And we're going to see in a second why I'm going to do that. But in the current setup, what is happening is that the audio is coming in into the audio sense device, is going to be sent into 1516. There's no audio going out of the actual track itself. So at the moment, everything is routed through the audio sense device. So let's just play the audio. But it's still reaching the Dolby Atmos renderer perfectly fine, obviously. Now the nice thing about this audio devices, or the audio sense device, is that we can actually use the fader in order to control the audio gain. So even though the audio is not going through the actual output and actually technically never reaching the fader can still be used in order to control the gain of that particular track, which is really nice. So let's add a multi-channel panner, and for that purpose I'm going to use the one from Music Unit that is based on the SPAT multi-channel system. You can get that from Ableton directly. I'm going to leave some links in the description below. And we have that here in the PACS, and here's SPAT multi-channel panner from Music Unit. And what we're going to do is we're going to use the spatial multi-channel. So there are a couple of devices that essentially this brings. The one that we need to use here is the spatial multi-channel panner here, and that will add the multi-channel panner. And then we need to add a couple of settings. So here we are. Now, first of all, there are a couple of things that are labeled slightly differently to the way you're used to when you're working with Dolby Atmos. For example, in the source, well, first of all, orientation, aperture is kind of fairly obvious, but width is sort of the separation of left and right speaker, and spread is sort of in Atmos speak the size of an object. There's also this axis here, and axis really means that is the direct signal, and we're actually going to switch that off later on. But just be aware that there are certain things that are not labeled in exactly the same way. They are usually kind of labeled in a Dolby Atmos project. You might want to read through the documentation in order to understand everything that's going on here. Now, there are a couple of things that we need to do. And the first thing that I'm going to do is I'm going to switch the panner over. Currently, I have the speaker layout to be set to 5.0. So what I'm going to do is I'm going to switch that over to 7.0.4. That is sort of Atmos style panning. And if I open up the panner here, so if I'm clicking on the panner here, I see the speaker layout, and I can move the position of the object around. Let me just kind of set that here in the center for a second. And then what I'm going to do is I'm going to route the individual tracks into our Dolby Atmos bridge, and I can do that by opening up the routing section here. So let's just open that up. And here we have the outputs that we can choose. So I'm going to choose, first of all, the left-right goes into channels 1, 2. Then essentially center LFE goes into channel 3, 4. Then we have the remaining speakers. And those are the speakers, oops, that goes into 5.6. And those are the speakers that usually are part of the Dolby Atmos bed. So those are the 7 or 8 actually horizontal speakers, including the LFE. And then we have the 4 overhead speakers, and they don't have a representation in the regular bed layout. So what we're going to do is we're going to route them into objects, and that's why we started our object count with object number 15, because we want to use the first 4 objects that are available to us. So we're going to send that into objects 11, 12, and 13 and 14. And then the final thing that I'm going to do is in the essentially kind of fact settings here, I'm going to simply turn off the direct signal, and that essentially makes sure that I'm only receiving the reverb or that portion of the reverb. Now, a couple of things that are really interesting about that particular device is that you actually have a lot of options here. And one of the things that you can do, for example, is in the distance settings, you can enable the Doppler effect. So this is actually a little device that allows you to recreate Doppler effects, and that's actually really nice. So this is an extremely capable Max for Live device. So if you're working with any form of surround sound, you might want to get that, because it's really, really useful. But here we're not going to bother too much about those things. I'm just going to once again turn off the direct signal. I could also simply mute the access, because the access is the direct signal, but that's fine. Let's just leave it like that. And that is pretty much everything that I needed to do. So let's just see what we get if I'm playing the audio now. And let's go into our Dolby Atmos, and I see sort of the channels are coming in 1 through 8. Those are the first 8 channels, and then we have 11, 12, 13 and 14. Now, if you paid attention to what I said so far, is then we're getting the audio information here, but we are not really hearing anything. And the reason for that is that we currently don't have any panning information. So the Dolby Atmos render receives the audio for channels 11, 12, 13 and 14, but it doesn't really know where these channels are. So in the next step, what we will need to do is we will need to add the music panner in order to tell the Dolby Atmos renderer where these 4 overhead speakers are. And here comes an important thing that I cannot stress enough. The Dolby Atmos Music Panner doesn't really influence the audio signal. So it doesn't really make any difference where exactly in our set we put the Dolby Atmos Music Panner. So we can put the Dolby Atmos Music Panner on this particular track, even though there is already one. It doesn't make any difference. We can add as many as we want to, as long as they are kind of pointing into different objects. Or we can put them on any track as we want. And in this particular case, what I'm going to do is I'm actually going to put them on the LTC track, because we are never going to change the position of those 4 overhead speakers. We just need the panner somewhere in order to tell the Dolby Atmos renderer where these 4 overhead speakers are. And the LTC channel is the best place to hide those 2 panners that we don't really need in our set at all. So let's go into the LTC track. And in the LTC track, I'm now going to add the music panner. And I'm actually not only going to add 1 music panner, I'm actually going to add 2 music panners. Let me just go into the plugins here. We're going to add 1 for the front height speakers. That is going to be routed into 11 and 12. And they're going to stay in the front, but I'm just going to move them onto the top. And you can fine tune that depending on where your speakers actually are, but I'm just going to leave them at the top front locations. And then I'm going to add a second one. And the second one, we're going to move that, or we first need to select object pair 13 and 14. Those are the back height speakers. And we're going to, once again, move them completely up, and we're going to move them back. And once I've done that, I can actually go into the Dolby Atmos renderer. And in the Dolby Atmos renderer, I now see that all 6 channels that I have, so the first 4 were those 4 overhead speakers from our artificial bed, and 15 and 16 was our first object. So the Dolby Atmos renderer actually now receives the panning information, and if I'm playing the audio now, the Dolby Atmos renderer essentially knows how to render that, and I'm getting the audio correctly. I'm seeing those 4 height speakers, and I just noticed that one of them is not completely on top, so let me just kind of go back here to the first one, and let's just kind of move that. Oh yeah, for some reason that was not kind of up completely. So let's just kind of move that upwards, and now I should actually hear everything. Yeah, and now kind of these are the front head speakers, not the top head speakers. Now, this is something that might confuse a lot of people, and I'm already seeing people kind of hammering away in the comment section. Didn't you just pen the timecode information? No, I didn't. Once again, the music panner is just there in order to communicate the panning information to the Dolby Atmos renderer. It has nothing to do with the audio. It does not influence the audio, so we just put the music panner on the track where the audio is in order to not get confused, really. But the music panner can be anywhere in our set. In this particular case, it was just useful to put them onto the LTC track, because we are never going to change the location of those four objects, actually, because they are sort of almost like a bed. We are going to use them that way, and we don't want to bother with them. So let's just hide them at the LTC channel and the LTC track, and essentially don't worry about those. So before we add the second track, or before we change the second track, let me first position the object a little bit. And what I'm going to do is I'm going to actually unlink the two left and right channels. So let me just move maybe the left channel on here on the left side and the right channel here, because what I want to have the call on the left side of my room. And just to make sure that we have a little bit of height information in there as well, let me just, for object 15, kind of move that up a little, something like that. And then, unfortunately, in this particular case, what I also need to do is I need to make sure that the panning information for the part that creates the reverb is also matching the panning in the panning of the object itself. So I need to also go into the panner of the spatial multi-channel panner here. And now, unfortunately, the way this panner works is that it doesn't really separate, or you don't really see left and right channel. Even though this is a stereo panner, you don't really see kind of the separation. So you need to play around with it a little on how that works best. What I'm going to do is, and I could technically also go into the essentially source settings, and I could kind of change the azimuth here and the elevation, for example, here. So maybe kind of let's move that up a little. And that seems to kind of fit that perfectly. I can also change the distance, obviously, and I can change sort of the separation, how far the signal is sent into the room. So I can change, for example, the aperture here, and I can make that wider or larger. And I can also change the width. Now, unfortunately, as I said before, the width is the separation of left and right channel, but we can't really see that here in our little panning device. So I would just leave that the way it is. And if you want to create objects that have a larger size, you can increase the spread here as well. And that is pretty much everything that I needed to do. And now I have essentially the object or the call on the left side of the room. So let's just play the audio again. So it's now on the left side. So let's just maybe only listen to the reverb, and I can do that by simply essentially kind of turning off the signal that is sent to the external out 15 and 16. That essentially means that there's now no signal sent into the object channel. So let's play the audio again. So this is now just the reverb part. And this is sort of the response. Now, when I talk about reverb, it's actually a little bit more than reverb, because this particular spatial multi-channel panner also has a couple of other things, other tricks up on his sleeve. There are also early reflections, cluster reflections. So it really is a room simulation. That's really what it is. And once again, I recommend that you read through the documentation, because this little device is extremely, extremely powerful. So let's complete our setup by doing exactly the same thing for our second track. And as we will see, that is actually fairly straightforward to do. So let's go back into our second track. So the first thing I'm going to do is I'm going to, since I already have that open, going to have a Dolby Atmos music panner. I'm going to send that to the next available pair, which is 17 and 18. And let's maybe also already kind of change the location. I want to have that on the right. And similar to what I had with the call, I'm going to move the object number 18. I'm going to move that up a little, just to have a little bit of height information in there. Then I'm going to send the signal to the Dolby Atmos renderer, and I'm going to do that with the help of our little Max for Live device. That was the audio sense device. I'm going to turn off the gain here, the gain controls, and I'm going to send it in the external output. I'm going to send it to 17 and 18. And then I'm going to essentially turn off the sense from the track directly. So I'm going to turn it over to sense only to make sure that there's no audio signal coming to the Dolby Atmos renderer from the track itself. It's just going to be sent through the audio sense. So if I'm now play everything, I already have the object in the right collocation. And I probably need to turn on the sense here again. So the object is already in the right location here. The only thing I don't have yet is I don't have the additional reverb yet. And for this purpose, what I'm going to do is I'm going to once again use the SPAD spatial multi-channel panner. I'm going to send it here. Now, you need to put that on every track that you're going to add a reverb into the SPAD channel. However, what you can do is if you have multiple spatial multi-channel devices here, what you can do is there is this little button here that says S. If I press on this button, it essentially propagates all these settings from one device to all the other devices in your setup. But here what I'm going to do is I'm simply going to kind of set that manually. So we have that 7.0.4, and then we need to set the outputs. We're going to send that to 1, 2, to 3, 4. Then we're going to send it to 5, 6, 7, 8. And the 4 overhead speakers are going to be sent into 11, 12, 13, and 14. And because the Dolby Atmos Music Panner, the Dolby Atmos renderer is already receiving the position information of those 4 objects, I actually don't need to add any panner anymore. Those are, once again, hidden in our LTC channel or in LTC track, so I don't need to do anything here. And that is pretty much it. So the last thing is I need to kind of change the routing or the positioning a little. What I'm going to do is I'm going to do the same thing that I did with the other one. So somewhere here, and also kind of moving it up a little because we had one of the 2 objects slightly elevated. And that should be pretty much it. And let's see what we have. Oops. As you can see, the reverb is coming in at channels 1 through 8. That's a little loud, so let's turn that down a little. Okay, so one thing I forgot to do, obviously, if you paid attention, you know exactly what I forgot to do, is I forgot to turn off the direct signal here. So let's do that. And let's play that again. And I can change the overall gain of object in together with reverb with the faders in exactly the way I'm used to. Now if I want to change the relationship between the object and the actual reverb, so essentially kind of change the immersive reverb or kind of change the gain of the immersive reverb, I can either kind of control the gain of what goes into the object channels here in the audio sense device, or I can also change everything here for the reverb in the spatial multi-channel panning device. Now, as I said before, I did the setup here with a 7.1.4 multi-channel bed. However, you can do any bed as you want. So one thing that you could do, for example, if you go into the speaker layout settings of this multi-channel panning device, you see that there are all kinds of options that you have. And let me just open up the panner that you see a little bit what we have here. And we can open up a dual panner that allows us to see that in 2. Let me just kind of make that a little larger. so from the top and from the back. What we can do, for example, is we can use one of the dome settings, and we could do this very same thing. The only thing that we would need to do is we need to add music panners for each of the individual speakers, and we can add them once into the LTC track and then essentially use them for all the other panners, and that is extremely convenient. So the only limitation obviously is because Dolby Atmos cannot have any speakers below listener level, so these settings need to be, or the surround settings or the surround panners that you use need to be panners that have the signal or have all the speakers located above the listener position. In this particular case, this is a dome setting where all the speakers are above, and I think all the domes that are used here in this device are pretty much in the same way. Yeah, they're kind of all set up that way. So you can do all kinds of things, and obviously you can also do the more traditional things like a 9.1.6 layout and do the very same thing, and everything works just perfectly fine. So as I said before, this is an extremely convenient setup. There's actually not much bulk that we add. The only additional track that we needed was this LTC track that we needed anyway, and that was the one track where we hosted the two music panners that gave the Dolby Atmos renderer the information where these two additional overhead speakers are. But everything else works exactly as expected. You can still use the faders and everything works just fine. And you can use that with all kinds of surround panners, not only the one that I used here. Any surround panner works just fine. If you're using the Mach 1 spatial audio system, for example, you can also embed that into Dolby Atmos in exactly the same way. Or if you're using the surround panner that comes with Ableton, also in exactly the same way, and it works just fine. If you're working with a different audio workstation, you can use exactly the same trick. The only difference would be the way you route the audio and obviously the type of panner that you use. But other than that, everything works in exactly the same way. And this is really everything I wanted to say today. Once again, thank you for watching my videos. Really appreciate it. If you have any questions or comments, please use the comment section below or join our Discord community. Email link is in the description below. And with that being said, see you at the next video.